I'm Ionuț Popescu, and I work as a senior penetration tester for SecureOx. Today we will talk about Windows shellcodes. A few things about me. I'm also the administrator of largest, actually it was the largest probably, security community from the Eastern Europe, Romanian security team. And last year I spoke at DefCon. I released NetReaper, a post-exploitation tool that captures encrypted traffic before it is encrypted, so you can get clear text from encrypted traffic. Check it on GitHub. Related to this conference, we also have a CTF contest in the Hacking Village. There are multiple challenges, 10 challenges, and multiple prizes. There are 2 laptops and some other prizes as well. Just check our booth on Hacking Village. Also, SecureOx is hiring. It's probably the largest security company from the Eastern Europe. So if you want to start a career or to develop a career in information security, visit our booth. This is what we will talk about today. I will introduce you a shellcode compiler. We will see later what it does. And we'll take it step by step. We'll see what is a compiler, what is a shellcode, what are the steps for exploitation, how process memory structure works in Windows, a few things about ASLR, the limitations that shellcodes might have. We'll see some examples on Linux shellcodes. We'll see how Linux shellcodes work and how Windows shellcodes work. Also, we will have a Windows shellcode example. We'll see step by step how it is written, and then we will see how shellcode compiler can make this easier. I will present you a few examples and 1 or 2 demos and some other details that might be useful for you. Okay, shellcode compiler. This is the description for the shellcode compiler. It's a tool that takes as input a custom language, C++ style, and compiles it as any other compiler in a shellcode that is small, null-free, and the code is position independent. You can use it to call any Windows API, so any Windows function, in a really easy way. The generated assembly file, it takes an input, the C++ style code, and generates an assembly file that is later assembled with NASM assembler. What is a compiler? This is the example for the C++ compiler, GCC for example. This is related more to those of you that know how to write, let's say, some basic hello world program in C. First step is to parse the defines. It doesn't matter, it's not important. And the second step is to compile the code. So you declare functions, write your code, and it is compiled. The compiler will output the assembly code. For example, if you work on Linux, it will output assembly code for Linux. This is what will also do our compiler. We'll take some code and output an assembly file. The assembly file is later assembled, and so on. What is a shellcode? This is the description from Wikipedia. Shellcode is a code that, from history reasons, gave back to the attackers a shell. So it gave to attackers remote access to a system that is infected or the attackers got access to. So today it's not really a reverse shellcode. So shellcode, it's any piece of code that does something useful for the attacker. For example, an attacker may not want to a reverse shell, may want to, I don't know, delete files to do something else. It is important to know that most of the time shellcode is written in machine code. So let's go back to the assembly process. The assembler will take as input the assembly code, and it will generate binary code that processor can understand. And the shellcode, being commonly written in machine code, means that shellcode is most of the time written in assembly. And as you will see, it's a bit difficult. Those are the steps for a generic exploitation. Let's say you exploit an SMTP server that is vulnerable to a stack-based buffer overflow, the easiest example. So first of all, you get the version information. Then you try to discover a vulnerability. For example, you send a large amount of data that maybe will overwrite some buffer and it will crash the application. After you crash the application, you analyze the crash in a debugger, and you see that if you send a specific set of bytes, you will be able to control the instruction pointer of that program. You write the exploit, and in order to do something useful with this vulnerability, you need a shellcode. You need a reverse connection, like a reverse TCP, or maybe you want to listen on a specific port to get a command shell, but maybe you want to do something else. Shellcode compiler doesn't have anything to do with the first steps. It's only required for the last step, the actual post-exploitation part of the exploit. Like what are you doing after you exploited it? This is the memory structure of a process on Windows. The process have the stack, a heap, the dynamic memory. Program image, it's the binary itself loaded into memory. The tab and peb are some specific structures for Windows that contain different information about Windows processes. And the DLLs are loaded into memory in a random order. As you can see here, ASLR, or address space layout randomization, is a security mechanism built especially for avoiding some of the exploits, like stack-based buffer overflows. What it does is to load the DLLs at different memory locations after each reboot. So even if at the first reboot the kernel 32, for example, is loaded at a specific address, after a second reboot it will be loaded at a different address. This means that the attacker cannot take in consideration when they exploit the vulnerability the fixed memory addresses for some DLLs that may contain useful code for them. I will not cover any details about exploiting a vulnerability because it's not in the scope of this presentation. Okay, so we exploit a vulnerability, we control the execution flow of a process, and we can execute code. But we have some limitations. When you write a shellcode, first limitation is the difficulty. It's really difficult to write a shellcode, at least on Windows. The second one, and it's pretty common for some shellcodes, is that they should be null-free. For example, if you exploit let's go back to our stack-based buffer overflow. If you exploit that vulnerability, that may be caused by an improper use of a string. Strings are terminated with a null byte. So if you use a null byte, your shellcode will not be complete. So most of the time we have to avoid null characters. Also, they must be small because you may not have enough place for the shellcode. In some cases, they need to be alphanumeric, so you cannot use different non-printable characters. And some of them, I don't know, you may want to avoid detection from IDS or IPS. So you'll need to obfuscate them, for example. Shellcode compiler doesn't do anything about the last two issues, like alphanumeric and detection, but it takes in consideration the three issues, and the first one is the most important, but it also takes care about the second one. So what will do shellcode compiler? It will be able to provide you a shellcode in an easy way, so it will not be difficult to write on, and it will be null-free. Let's see some examples on Linux. Let's see how shellcodes work on Linux. There is a specific instruction that the processor can understand. It's called int0x80. It's an assembly instruction that invokes a system call on Linux. The main idea of this instruction is that we can use it to generate system calls. System calls are, let's say, function calls for the operating system. So we can tell the operating system what he should do for us. And we'll see a simple example. There is a specific way on how to call these system calls in order to do something useful, but it's not important for our case. And here is the list of a few system calls. On Linux, you have system calls for most of the stuff you will need. For example, you can fork, you can read or write files or some other stuff. You can create processes and so on. You have most of the stuff already in the system calls. This is not also available for the Windows. For the Windows, it will be more difficult because even if there are system calls, they're not as useful as the Linux syscalls are. Here is a basic Linux shellcode example. As you can see, it's not so complicated. So what we'll basically do is to write something on the console. So it will write hello, and for this, it will call two system calls. It will call the write system call and the exit process system call. And as you can see, I will not cover every detail of this program, but you can see that it's not that complicated as it might look like. Let's go now to the Windows shellcodes. As I already mentioned, you do not have system calls to do something useful. Or if you have some system calls, they have 10 or 15 parameters, and it's difficult to write, and the shellcode will not be small. What is the better approach for the Windows is to use the functions from the DLLs. Windows has some basic DLLs that can use to do most of the important stuff, like kernel 32, user 32, and so on. So, in order to do something useful with the Windows shellcodes, we will need to call the functions from some DLLs. We can choose any DLL we want from the Windows. Okay, what can we do to call an arbitrary function from a DLL? Is to find in memory, even if it's loaded at a different address, the address of kernel32.dll. Kernel32.dll is a system DLL loaded in every process that contains a lot of useful functionality. Some of this functionality are two exported functions, LoadLibrary and getProcAddress. LoadLibrary is a function that loads a DLL into memory and returns the starting address of that DLL into memory. And getProcAddress takes two parameters. First one is the DLL address in memory, and the second one is the function name. So we can use those two functions in order to call any Windows API we want to call. So what a shellcode on Windows will do is to load specific DLLs that it wants to do, and it will call specific functions from that DLL to reach its target. Some common shellcodes are the following. The calc.exe, it just uses the WinExec function. WinExec function is exported from kernel32, and it takes a single parameter, which is the command line you want to execute. A really common shellcode is download and execute that will load a specific DLL called urlmon.dll that exports a function called url download to file. A single call to this function will download a file from the internet to the disk. A message box is a function exported on from user32.dll, and reverse TCP or bind TCP work with sockets and create a socket, connect back or listen to a specific port, then use create process and pass as parameters the sockets, and you are able to control the data that goes in and out to the process, which is cmd.x. So you have a remote shell. In order to properly understand how Windows shellcodes work, you need to understand the portable executable file format. Portable executable file format is the file format used for executables, DLLs, and some other stuff on Windows. So we'll see that we need to parse this type of data. This is what happens when you open a file in Notepad. You see something that looks like junk, but almost everything in that file does something useful in order to make sure that the application works correctly. So let's see step by step. This is the generic structure of an executable. It contains an MS-DOS header that it's not used anymore, then just prints a text that you can see in the notepad. This program cannot be run in DOS mode. After the DOS header, you will see the PE header. PE header contains important information about the executable, like if the file is a DLL or an executable and so on. After these headers, after the PE headers, you will find data directories. It's a table containing useful information about the executable. And second, last one, you will see the sections. The sections contains the actual useful data of that executable or DLL. For example, in .idata is a section that contains read-only data from that code. That data is, I think, read-write code. That text section contains the actual code of the application. Those are the first 256 bytes, I think, from an executable opened in an hex editor. This is the MS-DOS stub. It doesn't do anything useful for us, but it takes us to the PE header. This is the PE header, starting with PE and 2 null bytes. We can know in an executable that the PE header will start from that address. As you can see, the PE headers are not really easy to understand. They contain a lot of data, like the number of sections, the date when the executable was compiled, the characteristics of the DLL, and a lot of other stuff. We will need some of this information for a shellcode. I present you this because you need to understand how it's basically what you basically need to write a Windows shellcode step by step. This is a structure that describes a section header, like the text section. And this is the data directory that contains, for example, the export directory. For example, in order to get the exports, to see what functions a DLL export, we need to parse this data, all this data. This is some poorly written code that can extract the exported functions from a DLL. What is important on writing a shellcode is this PEB. PEB is a process environment block, and it's a structure that every process on Windows has. As I already told you, the DLLs are loaded at a random memory so we don't know where to find them. But fortunately, this PEB structure is always at the same address. So in a shellcode, and it's really important for us, we need to use this structure in order to find information for the process, like the DLLs loaded into memory. There are linked lists with all the DLLs, and it's important for us to note that the kernel 32 is the third one. So this is the assembly code that finds the kernel 32 address. It's not that complicated if you take it step by step, but it's not also easy to understand it. It just parses that PEB structure and parses its internal structures in order to find the kernel 32 address. Then you need to find the export table of that DLL. You find the export table and you loop into all exported functions in order to find the getproc address function. After you find the getproc address, you use getproc address function to get the address of the LoadLibrary function. As I already mentioned, you need those two functions in order to do anything you want with Windows process. So those steps are required for each Windows shellcode. What is easy on writing a Windows shellcode is that you don't need to write all this stuff every single time. You need it a single time, you write it a single time, and then you use it always. After you have this, let's say, header that resolves you the basic stuff you need for a Windows shellcode, you need to load the DLL. For example, for a download and execute shellcode, you will need to load the urlmon.dll into memory. And you just call LoadLibrary that you already have to load this DLL into memory. After you loaded that DLL, you need to find the address of the URL download to file function. You use the getProc address function that you already have in order to find the address of the URL download to file function. After you get the address of the URL download to file, you just call URL download to file with a specific URL and a specific file on the disk where the file to be saved, and the file will be downloaded. This is an example of a single file, a single function code. Then you want to execute the file. You download the file, but you need to execute it. So you need to find the address of WinExec function. We already have the address of the kernel32 because this function is exported by kernel32. So we find it using getProc address, and we call it. We just execute that.exe, which is the file name that we already downloaded with URL download to file. Then we don't want the process to crash, and we find the address of exit process, the function that will gracefully terminate the process. So we call exit process, and we executed our file, and we exited from the process. As you can see, it's not so easy to write a Windows shellcode, and this talk will come with a tool that will simplify a lot this kind of stuff. You saw already that there are some stuff that always happen, like you load the DLL, you use getProc address to find the function, and you call the function. And you will do this kind of stuff for every function call. So why shouldn't we automate it? Of course, you can try to learn assembly and Windows internals, but it will take you some time. And the easiest solution will be to use Shellcode compiler. This is the command line for the Shellcode compiler. As you can see, it takes some parameters. The most important parameters are -r that will read your source code, -o that will output the shellcode, the binary shellcode, and -a that will also output the assembly file. So you can take a look and maybe, I don't know, maybe you want to modify it. And you can also see an example of a download and execute file, but we will cover this later. Also, you can see an invocation example on how to use it. Let's see now an examples, actually a few examples. For example, the message box. You want to just display a message box to test if your exploit works. So instead of writing a lot of assembly codes, you just declare some functions. For example, for this shellcode, you need to declare two functions, messagebox A, which is exported by user32.dll, and exit process, which is exported by kernel32.dll. When you will specify those function declarations, the shellcode compiler will parse them, and it will automatically generate calls for LoadLibrary of user32.dll and kernel32.dll, which is already loaded, and it will use getProc address to find the addresses of these functions, messagebox A and exit process. Then you just call the messagebox function like you will call it from a C++ program, like in Visual Studio. You specify all the parameters in the correct order, and you call exit process with the exit code as 0, so everything was okay. And Shellcode compiler will generate the shellcode for those two function calls. Let's see what else you can do. For example, you can work with files and registry. Even if I have here two basic examples, like how to copy a file or how to delete a file, there are some stuff that may be useful for you as a pen tester. For example, you can take files from SMB or WebDev or I don't know, some other stuff and copy it to the target machine. Or I don't know, you just want to delete a bunch of files from the system and like htaccess, because you are blocked by the htaccess and you cannot access something, and you can have access to that feature. Like the previous example, you declare the functions and you just call it. Copy file, for example, will copy the calc.exe to the desktop. And the second, the delete file function will delete the file. Also, it might be really useful to change stuff in the registry. So you can use the reg set key value in order to change something in the registry. For example, you can disable stuff, or you can modify some stuff that may offer you some useful attack surface. For example, in the second example, I just modify a random key in software Microsoft Notepad, and I write something in order to test if it works. Here is something more useful. Here is the download and execute shellcode. What I presented you before was a download and execute shellcode. So it was, I can say, difficult to write it. But I think it will be a lot easier to write something like this instead of, I don't know, 200 lines of assembly code. So you just need to declare the functions url download to file, WinExec, and exit process, and you call these functions with your parameters. In assembly, you'll see that you might have a lot of problems because you need to push all the strings on the stack, and there are some stuff that can come with a lot of problems. But I'm pretty sure this is an easy way to create a download and execute shellcode. And I think everyone can understand what this code does. This is an example of a reverse shell, some kind of reverse shell. You download netcat.exe from a specific URL, and you just use netcat.exe to connect back to a specific location. So you have a reverse shell. As you can see, we only use URL download file and WinExec, and we can pass any parameter we want to the netcat.exe. Another thing that might be useful is instead of downloading an executable and execute it, it might help you to bypass the antivirus to download a DLL file. You download a DLL file and use LoadLibrary to load it into memory. When you use LoadLibrary to load it into memory, it will execute the code from that DLL. So this might be a really easy way to bypass antiviruses. Okay, let's see some examples. I hope the virtual machine will not crash. Here is the binary release for the Shellcode compiler. It's the basic executable and the NASM assembler. It will compile our source code into assembly, and it will use NASM to assemble the final file, the final shellcode. For example, this is the download and execute. It will download calc.exe from a specific URL and execute it. Let's see if it works. It happened to crash, so I'm not 100% sure if it will work. A -r will specify the source code file, which is download and execute.txt. -a will output the assembly file, and -o will output the binary shellcode. And -t will test the shellcode, will actually load properties. Yeah, no idea how can I change the font. Yeah, I don't think I can. Oh, size. It doesn't work. Okay, better? Okay, so the -r parameter will specify the source code file, which is this one. That will download the calc.exe and execute it. And the -a will output the assembly file, and -o will output the shellcode. And -t will test it. So it should work. So it downloaded calc.exe from that URL. It generated an assembly file. that contains what we thought about. So it doesn't repeat the stuff that you need to repeat for every function call, and it will generate this assembly for you. This assembly, being assembled with NASM, will generate this shellcode. So this is the final shellcode that you can use in your, I don't know, test. Okay, let's see a second example for the download and load. This is the example that I told you about. This will download a file from that URL. It's a DLL. It will download it as sc.dll, and it will call LoadLibrary to load that DLL into memory. Loading that DLL into memory will automatically execute its code. So it's download and load, I think. So it downloaded the DLL. The DLL is called sc.dll, and loading the DLL into memory executed the content of the DLL, which is only a message box that shows this message. So those are some basic examples of what you can do with the shellcode compiler. Okay. However, it's an alpha version and it has a lot of limitations. The most important limitation is that you can't use the return value of an API call. So if you'd like to, I don't know, open a file, you'll need to call a function called createFile, and this will return a handle to that file. But you can't use it right now, the return value. Also, it is not possible to use pointers. For example, if you want to write some data or to call read file to get some data from a file, you'll need to pass some pointers with some specific buffers. And also, it is not possible to declare variables. However, all of this will be fixed as soon as possible. I already know how they are going to be implemented, but it will take some time. This is the alpha version, so we expect any crash and so on. Also, it's not as powerful as the GCC compiler, for example. It doesn't show you any warning or error, it will just crash. So please be careful when you use it. Also, stupid issues does it have is that you should not write tabs and indent your code because the state machine that I used for the compiler doesn't take in consideration those characters. Also, I want from it to support some arithmetic operators, like to add some numbers and concatenate some strings, but I didn't have too much time to work on this, so it doesn't have them right now. I also want to make it support \x characters, like I don't know, you may want to use some specific characters in your non-printable characters in your function calls. I will work on these features as soon as possible in my limited time, but I will make sure it will have all the functionality you will need to write your own shellcode, and you should be able to do something useful with that shellcode. If you are a beginner on Windows, you can find on that URL an index with all Windows API functions on categories. For example, for the user interface, for the shell, for graphics and multimedia, and so on. And you might find some useful functions right there. For example, there might be function to execute WMI code or something more complicated than the basic stuff. So you might find that useful. An important thing on writing, on directly calling functions from Windows is that many of the functions that most of the time that works with strings have two versions. So DLL will export like URL download to file, we export two functions, URL download to file A and URL download to file W. This is for the Unicode support on Windows. So for the A, URL download to file A, you will use SC characters. And for the W version, you will need to use Unicode version of that string. It doesn't have support for Unicode right now. So you should always use the A version of the functions at this moment. This is how it works. It uses a DFA. It's something from algorithms, deterministic finite automaton, that will parse, use the states machine, and it will parse the code and generate the assembly code. It also takes in consideration the null bytes, and it tries to avoid them. However, there might be some calls that might generate null bytes. So, as I mentioned, for every function call, like WinExec, it will call LoadLibrary, it will call getProcAddress, and it will call the function name. You will find the project at this address, including examples and the binary release. It's private right now, but I will make it public immediately after this presentation. And here are some links that I find really useful. First two of them are an in-depth description on how Windows shellcodes work. And you will find it step by step how to manually write one. You will notice that it's easier to use shellcode compiler. As a conclusion, shellcode compiler is a free tool that takes some custom code where you declare functions and call functions, and it will output a shellcode that it's small, position independent. It doesn't contain null bytes. Please know that it's the alpha version, so it might have a lot of problems, and you can use GitHub to report any of these issues. If you have any question.
Sorry, so to repeat the question, do you plan on adding support for bad characters, other than null bytes and what you have there?
Yes, I thought about this, but it might not be reliable. For example, I plan to add support for some, for example, \r/n, some basic characters, but I cannot add support for more characters because I will need to write specific assembly code that will work with avoiding specific characters. It might be possible to add this kind of stuff, but only for the basic useful characters.
Okay, thanks.
Have you tried to extend an existing compiler? Maybe it was easier just instead of starting from scratch.
I thought about this, but I really thought about this, but the work would be the same because however, I would need to do something like this. It is possible to, and I forgot to mention this in the presentation, it is possible to write shellcode using a Windows compiler like Visual C. There are some tutorials, and they are mentioned in the links section. There are two really good links about this. And you can really write optimized shellcodes that will use specific characters that you don't normally use. But the main issue I didn't want this is because I wanted to avoid the null bytes. And I wanted to have full control about the generated code. By using this, I make sure that I avoid null bytes, and in the future I might avoid some other characters as well. And you do not have this type of control with any compiler. And taking a compiler from the source code and modify it might be a lot more difficult than this.
Okay, thank you.
Can I ask you now? Here. So, I wonder, do you have in mind to use some self-encryption, self-decryption methods or subroutines that are actually added automatically when the compiler starts to actually link the files? Because if you write the shellcode in C, for example, or C++, and use NASM to compile it, it will compile and link it. But the source code will be the same if someone uses any disassembler like OLIDBG or IDA Pro. So it's worthless to work on a shellcode, to write the code, and someone to just modify it as they like. I mean, like self-encryption, you can use any XOR for basics, and then to use some polymorphic stuff.
Yes, I thought about some, let's say, obfuscation mechanism like SOR or some other stuff. I didn't have time for this. And I even plan to use the Mofuscator, if you know about it.
Yes, I know about it.
Yeah. It's a tool that generates the assembly code only using mov instructions, and there are some other add, XOR, and some other instructions as well that might be useful. But I really didn't have stuff, but I will try to do as much as possible on this.
So for the moment, the best choice is just use the stack functions like push and pull,
Yes.
or just move it without pulling to
Yes.
keep the top of the stack, just in case of null pointers.
Yes, I just want to avoid null bytes at this moment.
Okay,
I
thank
only
you.
had the weekend something for this.
Yeah, I get it. Thank you.
So there is some functionality in Metasploit. You definitely know about that. There are existing shellcodes. There is possibility to avoid bad characters. So what is missing there? What motivated you to do this? Or maybe to use like a shellcode for downloading and executing a file?
In Metasploit or MSF Venom, you have some basic shellcodes that you can use, like download and execute like reverse shell, bind TCP, and so on. But if you would like to work with files, to write into a registry and so on, the way you would like, it will not be possible. So this extends somehow the functionality to create custom shellcodes. You are limited to that, I don't know, a few shellcodes that on Metasploit, and you can do anything else. And about the encoders, you can use that those encoders like Shikana, Ganai, and so on these generated shellcodes, and they should work. So if you want to avoid some bad characters, you can use those encoders to bypass this limitation.
So that answers the colleague's question. That's good. And how about downloading a code without saving it to the disk and running it?
At this moment, it's not possible. You can use some functions like WinINet and so on, but you need to work with buffers, and it doesn't have support for buffers right now.
Mm-hmm. Okay. Thank you.
If you have any other question, you can talk to me after this presentation. Thank you.